Today we are looking at angular projectiles. And just a quick review, you should now know about horizontal projectiles. You should know which way acceleration occurs while in the air. You should know how to calculate the change in horizontal velocity. There is no change. The change in vertical velocity. Should be able to calculate the range for horizontal projectiles and how long it takes for an object that is thrown sideways from some high place to land on the ground or to drop a certain distance. But today we're talking about angular projectiles because not every projectile is thrown horizontally off a cliff, right? Perhaps you just are playing catch in the yard with some friends, or perhaps you're playing volleyball and passing the ball to someone else, or perhaps you're playing basketball and shooting the ball. In each of those cases, we're starting from approximately ground level and then pushing the ball into the air, having it fly through the air at an angle before landing where we want it to. Let's start by taking a look at some punters and see how they contact the ball. What do you notice? What is he trying to accomplish? That ball was in the air for about 5 seconds. Let's see another one. 1,002, 1,003, 1,004, 1,005, 1,000. Right, longer than 5 seconds that ball remained in the air. As an NFL punter, his job is to keep the ball in the air as long as possible at times. So that incredible hang time, how did he produce that? Well, if you noticed, he kicked the ball almost straight up. He put so much vertical velocity on that ball, and that's because vertical velocity is all that matters in terms of hang time. It's not a horizontal issue. So time in the air is only a vertical issue. And three things are related: the vertical velocity initially, the hang time, and how high the ball goes. The three of those together make up all the things to do with vertical velocity in projectiles. But if instead, so again, in order to kick a ball as high as possible and get the greatest hang time possible, you kick the ball as hard as you can upward. But what if instead you're looking to have a ball go as far as possible, increase the range as far as possible? So for that, let's take a look at another part of the camp.
Woo!
Go, 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 go. Yeah.
515.
Maybe I should push off more often.
The Massey champion.
515.
So once again, we see a pretty stunning performance by an NFL kicker. I think these guys are coming out of college and trying out this Coles kicking camp. But in any case, what you saw was a very different style kick, right? I mean, that was something like a 80-yard punt. He didn't kick it straight up. He didn't kick it mostly up. He kicked it equally up and forward. He kicked it up to give it time in the air, and he kicked it forward to give it horizontal velocity. And what you should know from our last couple days is that the range of a projectile is the product of two things: time in the air and horizontal velocity. So, hopefully, you can see how this relates to what we've been doing recently. And to take a closer look at that, let's move over to the dot cam. So, let's say we have a punter. Punter is going to take the ball and give it a 40 meter per second vertical velocity and a 10 meter per second horizontal velocity. Again, he is going to emphasize the vertical velocity because that's what matters in terms of time in the air. What happens each second? Well, 1 second later, the vertical velocity has reduced to 30 meters a second, while the horizontal remains the same because there's no horizontal acceleration, right? A second later, the vertical velocity has dropped by another 10 meters per second because of gravitational acceleration. After another second, It's down to 10 meters per second. And then finally, at the peak, at the apex, we know that the vertical velocity is always 0. That's because that's where it stops going up and starts coming down. And then we have the opposite occur, negative 10 meters a second, 10 meters a second, negative 20 meters per second, 10 meters per second, negative 30 meters per second, 10 meters per second, and negative 40 meters per second. And so how long was this ball in the air? Well, this is 0, right? This is time 0. So 1, 2, 3, 4, 5, 6, 7, 8 seconds. Can we see the relationship between the initial vertical velocity? Sorry, that wasn't on the screen all the way. Can we see the relationship between the initial vertical velocity and the time in the air? 40, 30, 20, 10, 0, negative 10, negative 20, negative 30, negative 40. Every second, the velocity is dropping by 10, meaning that if it went 40 meters per second, it takes 1, 2, 3, 4 seconds to reach the apex, and 1, 2, 3, 4 seconds to come back down. Let's put that in formula term. Final velocity equals the initial velocity plus acceleration times time. We know that the final velocity at the apex will be 0. The vertical velocity. We're only worried about vertical right here. 0 equals 40 minus 10 times t. How long does it take to get to the apex? 0 equals 40 minus 10t. I'm just going to write that again because I wasn't paying attention. So that means 10t equals 40, which divide both sides by 10, and we get that t equals 4 seconds. It takes 4 seconds for the ball to get to the apex. How do we know? Because the initial velocity of the ball was 40, and the final velocity at the apex will be 0. Again, only dealing with vertical because vertical is all that matters regarding time in the air. What about the total time that the ball's in the air? Well, isn't it just double that? 8 seconds rather than 4? Because it spends as much time going up as it does coming down. But let's look at another way we could solve this. Vf equals Vi plus At. What if we put in our final velocity as the negative of the initial velocity? Because we know on its way back down, it will be going the same speed as it was on the way up at that same height. So Vf equals Vi, which is 40 minus 10 times time. So negative 80 equals negative 10t. 8 seconds equals t. Notice it is double the time. Is there another way to do this? Absolutely. Could we do this, figure out the time in the air using the same method we did with horizontal projectiles? Absolutely. Let's do it. Delta y equals VIT plus 1/2 AT squared. What is delta y? It starts at ground level, goes up into the air, and comes back to ground level. What is our vertical displacement from beginning to end? 0. The initial vertical velocity was 40 times time plus 1/2. The acceleration is negative 10 times time squared. 0 equals 40t minus 5t squared. 5t squared equals 40t. Divide both sides by 5t. Don't tell your math teacher we're doing it this way because we are not dealing with the square, right? T equals 40 divided by 5 would be 8 seconds. Again, don't do this in math, because in math, the answer would be positive or negative 8 seconds, right? But in physics, we don't care about the negative time. So 8 seconds. Notice we have 3 different ways of getting the answer. You can choose which way you like, but this is how we get the time in the air. Why do we care? Or you just count the way we did here and draw it out. But why do we need the time in the air? Well, one, this is our hang time. This would be an incredible hang time. This would be like best in the NFL hang time. Look at this guy, this incredible punter, robot man, whatever he is. Cannon for a leg, quite literally, attached a cannon to his leg and is firing footballs out of it. With 8 seconds, you could just like punt on first down and gain so much position. Just run downfield and immediately tackle the guy when he catches it. 8 seconds. Shoot, you could walk downfield and tackle the guy. Okay, so besides the unrealisticness of this situation, um, what are we going to do with this knowledge now that if the ball's in the air for 8 seconds? Can we figure out the range now? This was our time in air, hang time. Now let's do the range. The range is simply delta x equals vt, same way we did horizontal projectiles. Delta x equals the horizontal velocity, which was 10, times our time in the air, which is 8, so delta x equals 80 meters. It's a incredible punt. Incredible punt. All right, let's solve a problem like this in another way. Let's do it all in one go. We have a ball being thrown up. Let's say it has a vertical velocity of 30 meters a second, still very substantial, and a horizontal velocity of 40 meters per second. Now this is a t-shirt cannon firing a t-shirt. Of course, how fast is it really going? How fast if it's being thrown or fired out of this t-shirt cannon, how fast is it truly going? It's not going 30, it's not going 40. 30 is the speed it's going up. 40 meters a second is how fast it's going sideways. What is the total speed with which it's moving? Well, to do that, let's use that's what we call the resultant velocity. Really, it's more of a speed because we don't have direction. But for that, we're going to use Pythagorean theorem. Why? Because what we have is 30 meters going up and 40 meters going right. And so we're finding the hypotenuse of this triangle. Now, since it's a hypotenuse of the triangle, you already know that it's going to be greater than either of those numbers, right? So let's plug in a squared 30 squared plus 40 squared equals c squared. 3 times 3 is 900 plus 4 times 4 is 16. 100 equals c squared. 900 plus 1600 would be 2500 equals c squared, right? 2500, which would then be 500, or no, 50 equals c. Get the square root of each one, and we end up with 50. So 30, 40, 50. I feel like that's a known triangle identity probably. So 50 meters per second is our resultant speed. That's how fast it's actually moving. Always use the Pythagorean theorem there. Technically, I'm sure you could use other trigonometric effects, but without the angle there, I'm not sure how that would work. Okay, okay, so let's work out a couple of things. One, what is the time to apex? 2, what is the highest point of its flight? 3, what is the range? And 4, what is the hang time? And 5, what is the final resultant velocity? Okay, so we have 5 quick questions here. Let's do them in order. Number 1, what is the time to the apex? So 1, VF equals VI plus AT, time to apex. What do we know about the vertical velocity at the apex? It is 0. The initial vertical velocity was 30 meters per second, says it right here. In fact, we should write out our givens. Vertical is A equals negative 10, Vy equals 30 meters a second squared, and delta y is 0. because it goes up and comes back down. Now this is not true for the height of the apex. This would be the total time when it goes up and comes all the way back down. We'll have a different delta y when it gets up to the highest point, of course. All right, so 30 minus 10, that's our acceleration times time. So 10t equals 30, so we get t equals 3 seconds. That's how long it takes to get to the apex. What is the highest point? Delta y equals VIT plus 1/2 AT squared. Notice we're looking for how high, so we have to use something with delta y in it. Delta y is what we're looking for. VI is 30 times our time, which we have right here, 3 seconds. We ought to add that. Time equals 3 seconds to top, peak, to apex. Okay, plus 1/2 negative 10 times 3 squared. Let's chug away. 3 times 3 is 90. Minus 5t, or 5 times, excuse me, that's not a t. 3 times 3 is 9. 5 times 9, delta y equals 90 minus 45. So delta y is 45 meters. That's how high it gets at its highest point. Notice we got the time to the apex, and then we plugged it into our displacement formula to figure out the height at that time. All right, let's do number 3. What is the range? Okay, so we honestly should do this in backwards, right? We need the hang time in order to get the range. Now, you could do this the easy way. We could say, hey, it was up in the air for 3 seconds going up, therefore 3 seconds going down. The hang time is 6 seconds. That'd be easy enough. But let's say we want to make life a little harder. Let's do delta y equals VIT plus 1/2 AT squared. Delta y is 0. Right? Because it went up and came back down. VI is 30 times time. This is not our time. This was the time on the way up. We want the total time, way up and back down, minus 10t squared. So 0 equals 30t minus 5t squared. 5t squared equals 30t. Divide both sides by 5t. Again, don't tell your math teacher. That'll get rid of that. T equals 6 seconds. That's the time going up and coming back down. Is it double the time on the way up? Yes, it is, right? That's the way we can check ourselves. Okay, so now we've got the range, we've got the hang time. Now let's figure out the range. This is hang time. Now let's get range. Range, delta x equals vxt. Delta x. Are we going to use this information? No. This information? No. This is vertical information. We are using horizontal information now. Horizontal only. So, what is our horizontal velocity? Let's go back up here. 40 meters a second. What is our time in the air? Time is not vertical or horizontal. It applies to both. What is our time in the air? 6 seconds. 6 times 4 is 240 meters. That's our range. Finally, let's figure that final resultant velocity. 5. What is the final resultant velocity? We know on the way down, it's going to be going the same speed as on the way up. So when it reaches the ground, its downward velocity will be 30 meters a second. Its horizontal velocity will still be 40 meters a second because that doesn't change. Let's change these so they're head to tail. 40, 30. Let's now figure out what that resultant vector is. A squared plus b squared equals c squared. 30 squared plus 40 squared equals c squared. 3 times 3 is 900 plus 1600 equals c squared. All right, 2500 equals c squared. 2500, that's 50. Same number as we did before. 50 meters per second. 50 meters per second is our resultant velocity at the end. All right, so at this point, what should we know? What should we know? Sum it up. Horizontal velocity. Velocity is constant. Vertical acceleration is -10 meters per second squared because of gravity, because of gravitational force. We know that range is horizontal velocity times time in air. We know time in air is a factor of vertical velocity, acceleration, and height. Right? Those are things, those are our basic understandings. A quick review. What do you need in terms of formulas for time and air? You can use delta y equals VIT plus 1/2 AT squared. Remember, set that delta y to 0 if it's coming back down to the same height that it started from. Make sure this is your vertical velocity, and make sure this is -10 meters per second squared. What about your range? Range is just delta x equals VT. What if instead you want to find the time that it takes to get to the apex? Apex time. VF equals VI plus AT. Make sure you plug in 0 as your VF. Your initial vertical velocity is VI, -10 as your acceleration. And then to figure out the highest point, take this time and plug it in to your displacement formula. Highest point, use delta y equals VIT plus 1/2 AT squared. All right, we've done examples and I've given you the basics. Hopefully you are comfortable with this. Make sure that you are taking a look at the questions from today, the tiered full parabola problems. If you have any problems with that, make sure you send a message. I wish you the best, and we'll have a quiz tomorrow.